welcome back, guys. We're going to be starting chapter 2, okay? You can see I'm actually in my office for this one, so chapter 2 deals with descriptive statistics. So when you have a data set, you try to let the data tell you a story, so we're going to be talking about that some. Now, section 2.1 right here, as you can see, this is on what are called frequency distributions, and then we're going to look at some other graphs. And the reason this is important, guys, is because, you can have a set of data, and just looking at a set of data is not going to tell you much. I'll give you an example. If I scroll down here in the notes, so right here, for example, this is a data set. Okay, it consists of 30 different data values. Now, just looking at this, I'm not seeing really any trends here in the data. Okay, so that's why we need these frequency histograms or frequency distributions, and we'll see frequency histograms as well. We need a visual way to look at the data so that the data can more readily paint a picture for us or tell us a story, okay? All right, so the learning objectives, we're going to look at how to construct a frequency distribution. I'm going to do one by hand. You guys will have to do these in your homework, including limits, midpoints, relative frequencies, cumulative frequencies, and boundaries, and we'll talk about what those are specifically here in a bit. Also, how to construct frequency histograms, so that to which I alluded to a minute ago, frequency polygons, relative frequency histograms, and then ogives. Okay, these are all visual ways of displaying data. Okay, so if you have a data set, guys, you really just have a bunch of numbers. You could put those numbers in a chart or in a spreadsheet. But until you really do something or organize those numbers, you're not going to get an idea of what the data is trying to tell you or any sort of trends with the data. And so a good way to actually organize data is using what's called a frequency distribution, okay? And these will pretty readily show you any patterns or trends in the data. And this basically consists, guys, of creating these classes. So if I have a data set and I've got all these different numbers, then I may create a few classes or intervals, and I'll try to see how much or how many data entries actually fall in that one class, and then how many data entries fall in the second class, etc. So that's kind of the way we go about organizing the data. All right, so this is the actual definition. It's a table that shows classes or intervals, okay, so these two terms are interchangeable, of data entries with a count of the number of entries in each class. So, if I'm measuring monthly grocery bills, one class might be between $700 and $799, and then the next class might be $800 to $899, okay? And then I would just see how many data entries fall into each of those classes or intervals. And then the frequency of a class is the number of data entries in that class. All right. Okay, so some other terms that we're going to look at. Each class, because it is an interval, is going to have a lower class limit, okay, which is the least number that can belong to that class. And similarly, it's also going to have an upper class limit. And then the class width is going to be the distance between the consecutive lower limits of two consecutive classes, or you could use the upper limits. So this example right here, you can see, now we don't actually know what the data is, okay, but we can see that these classes, my first class goes from 0 to 5, and my second from 6 to 10, etc. So the difference between these two consecutive lower limits is the class width, or you could use the two upper limits. Okay, so you can see that difference is going to be 5. And then the difference between the maximum and the minimum data value itself is what we refer to as the range of the data. Okay. And so, like I was talking to you a second ago, the lower class limits in this frequency distribution, and that's what this is. Okay, we've got, as you can see here, 6 different classes, and over here in this right-hand column we have the respective frequencies. So evidently from our data set, although we don't see it, 5 of those data values fell within this first class. And then 8 of those data values fell within the second class, etc. Okay, so that is a frequency distribution. The upper class limits, though, guys, would just be 5, 10, 15, 20, 25, and 30. And then the class width is 5, because if we take 2 consecutive lower class limits or 2 consecutive upper class limits and subtract them, we're going to get 5. And then it says, suppose that the maximum data entry is 29. We say suppose because we don't actually see the data. And then let's suppose that the minimum value from this data set was 1. So then the range would be the difference in these two values. 29 minus 1 is 28. So we could say that the data has a range of 8. All right. Okay, so we're going to do one of our own here in just a minute. See, I've got a table ready to go. But we're going to look at these guidelines first. So let's say we've got a data set. So in our case, we're going to be working with this data set right here. And this is, it says the data set lists the out-of-pocket prescription medicine expenses for 30 U.S. adults on a recent day. So, this is just for one day. This is actually a bit shocking. Anyway, and it says here we want to construct a frequency distribution that has 7 classes. Alright, so this is the way we're going to do it. Decide on the number of classes. Well, we're doing 7. And all of these problems in your homework, they're going to dictate the number of classes that you need to use. Now, when you start working on your statistics project and you have data of your own, then you're going to let the range of the data kind of dictate the number of classes and also the width of the class as well. Typically, you don't want too many classes and you don't want too few. So 7 is actually a good number. Alright, so we're going to find the class widths. So this comes from the range divided by the number of classes. And then you're always going to round up. Okay, so for example, if you got 2.8, 2.3, 2, any of those, you always round up. Okay, so you'd round up to 3. And that would be the class width. And then once you know your class widths, you can start setting up your classes. The first class, the minimum data value is going to be the starting value of that first class. And then from there, you're going to add whatever that class width is to find the rest of those lower class limits. And then you'll go back and find those upper class limits. I'll illustrate this here in a minute. This will make more sense. Classes cannot overlap. And then the last class must contain the maximum data entry. Okay, but it doesn't necessarily have to end with the maximum data entry. So once you've got your classes developed, then you're going to tally the data. You're basically going to figure out how many data entries fall into each of those classes. So you look at your first class, And you'll go to your data set and you'll literally count how many data entries are within that first class. And that's going to be your frequency. And then you'll do that for each subsequent class. Okay, the way it's been done in this example right here. So you got your classes and then the corresponding frequency. All right, and then there are some common add-ons to frequency distributions. This up here, guys, this is a basic frequency distribution. This shows how the data is distributed. So looking at this, you can see the bulk of the data is sort of right here in the middle in these three classes. Anywhere from 6 all the way up here to 20. That's where kind of the majority or the bulk of the data is. All right, but there are other things we add on to a frequency distribution. We have other columns, okay, not just the frequency. So one of them is called the midpoint. The midpoint of the class, to find that, you just take the upper and lower class limits, you add them together, divide by 2, and that's the midpoint of that class. And then there's also something else called the relative frequency of a class. So what this is the percentage of data that falls in that one class. So the way you find the relative frequency is you find the number of entries that are in that specific class and you divide it by the total sample size. So for example, up here, if I wanted to find the relative frequency of this class, 11 to 15, I can see that there's 6 data entries in that class, and so I would divide 6 by the total number of data entries, or the total number of frequencies here listed. And that's going to give you a decimal. And a decimal is fine, but you can also convert it to a percent by multiplying it by 100. Okay. Sometimes you have to be careful with round-off error with these relative frequencies. And then finally, the last thing that you typically see is something called the cumulative frequency of a class. So it's actually the sum of the frequencies of that particular class and all the previous classes. Okay, so for example, if I'm looking at this frequency distribution, the cumulative frequency for this class right here, 11 to 15, would be the number that are in that one specific class and all the classes below that. So 6 plus 8 plus 5. That would be the cumulative frequency. So it's the frequency of all the data that's in that class and then every class that's lower. All right, and then the cumulative frequency of the last class is always going to be equal to the sample size. And guys, you're going to see this throughout the course. We use a lowercase n to represent the size of the sample. And then we're using this italics F to denote the frequency. So you'll see these variables used throughout this course. So n typically always refers to the size of your sample. All right, so let's actually try one, because I imagine that a lot of this stuff does not make sense until we actually apply it. Okay, so it says construct a frequency distribution. Well, we're going to do a lot more than that, because we're going to also find these add-ons. Okay, so we've got this list of out-of-pocket prescription medicine expenses for these 30 different U.S. adults. Okay, so we have 30 different monetary values right here. So this is our data. And guys, before I actually started the video, I went back to figure out what the lowest and highest value was, because I didn't want to spend forever doing that. So the first thing we're going to do is we're going to find the range. So the range is the difference between the highest value, which I have underlined, which is, unless I made a mistake, seems to me to be 405. So the range is the difference between the highest value, or the maximum value, and the minimum value in your data set. And so I believe the minimum value here to be 155. I'm going to actually label this. Okay, so that's the maximum, and this is the minimum. And when we subtract these, what are we going to get? I want to say 350. I'm just going to double check in my calculator here. Whoops. Oh, 250. Wow. Oh yeah, definitely not 350. I'm not sure what I was thinking. 250. Okay, so that's the range in the data. Now to find the class, or the class width, what we need to do is we need to take this range and we need to divide it by the number of classes that we want to use. Well, you can see up here, we're looking at using 7 classes. Okay, so I need to take the range and divide that by the number of classes. And remember, we always round up. You round up, guys, to make sure that your classes are wide enough and they extend an interval long enough to encapsulate all the data. So 250 divided by 7. Let me use the calculator again. We get 35.7, etc. Well, I'm going to round this up to 36. This is 36. That's our class width. All right, now with that, we start with our minimum value. That becomes the lower limit of your first class. And unfortunately, I did not make the column here, the class column. I made it the most narrow, and it probably needs to be the widest. Oh well, we can still manage. So the lower limit is going to be 155, and then what we do to find the lower limits of these following classes is we add 36. So we say 155 plus this 36. Oops. So 155 plus 36, and the lower limit of our next one is 191. Then we add 36 again. Okay, so you just keep doing this. And you get to 127. Another 36, I get 263. Another 36, we get 299. Another 36, guys, is going to give us 335, and another 36 is going to give us, what is that going to be? 371, if I'm not mistaken. Okay, now how do we find these upper limits? Well, if 191 is the lower limit of my second class, then one less than that should be the upper limit of my first class. So this should be 190, okay? And the same thing for the next one. If 227 is the lower limit of my third class, then the upper limit of my second class should be one less than that, so 226. And guys, you just keep going. Or you could just start adding 36 again, okay, to get the rest of those upper limits. All right, but I'm just going to keep subtracting 1. So 263 minus 1 will be 262. 299 minus 1 will be 298. 335 minus 1 will be 334. 371 will become 370. Oops. And then this one I'm just going to add 36 to, so that would take me to 406. All right, so these are my classes. So now what I need to do, let me zoom out again because we need to be able to see both of these. Now, you can do the tally marks if you want. That's not actually necessary. What's really necessary is just determining the frequency. But the tally marks are not a bad idea, guys, because, well, let me keep these underlined. I'm going to get a different color. Do red, orange. Because when you find one in this class right here, you can scratch it out from the data set and you can make a mark. So we're looking at the class 155 to 190. So including both of those values. So that means we can include 155. So that's 1. Let's see what else. 165, that would be 2. And I'm just going to keep going. Let's see, 195. Oh, that's beyond. 195 is beyond that class, so be careful. But I do see 168, so put another mark. Okay. Now, I can get another color if I want. Now I'm going to try to see how many are in this second class, 191 to 226. It would definitely be the 195. And then the 200. Okay, there's only 2 there. You gotta be careful on this part, because if you make a mistake, 227 to 262. So that one would fit. Mm. 256 would definitely go. 241. 238. That's really all I'm seeing, okay? This next class, 263 to 298. Oh, wait a minute. I think I missed one. That last one. The 239 goes in this class as well, and that actually makes 5. All right, so now for the fourth class, 263 to 298. Well, this one, both of these entries would go. Goes all the way to 298, so I can include that one. I can include the 271 and the 290, so 3 more. So 1, 2 makes 5, and 3 makes 6. And then from 299 to 334. Here's 303. 307. 315. 330. 317. 306. 312. And I believe that'll do it. Now 335 to 370. We don't have too many left. 335, okay, so this one would work, that's 1. This one will, that's 2. 342 will fit. 345 fits. So how many is that? 4 so far? So I think 4. 1, 3, 4. And then finally, guys, in this last class, I think, well, we're going to capture the 384 and the 405 and the 400. So three of them, if I'm not mistaken. 1, 2, 3. Okay. All right. So now, the frequency in the first class is 3. In the second class, it's 2. In the third class, it's 5. Fourth class, it's 6. Fifth class, it is 7. And then we've got 4 and 3. Okay? All right, now for the midpoint. What we do is we actually add the lower and upper limits together and divide by 2 to find that midpoint. And once you find the first midpoint, guys, you can find the rest of the midpoints by just adding the class width. So 36 in this case. So 155 plus 190. Now divide that by 2. And that gives me 172.5. Okay. And then for the rest of these, I could just add 36 if I want to each one. So I could say plus 36. That'll take me to 208.5. Add another 36. We've got 244.5. And we've got 280.5. $316.5. $352.5. And last one, 388.5. Okay. All right, so we've got the midpoints. Now we want to find the relative frequency. Well, the relative frequency is going to come from the frequency of this particular class divided by the total sample size, or the total number. And guys, we know the sample size here is 30. I do want to make sure that my frequencies all add up to 30. So this would be 5, that's 10, 16, 23, 7 more makes 30. Okay, you can always check this. All right, so for this first one, I would take 3, divide it by 30, and write that as a decimal or percentage. Now, as far as the homework goes, it'll typically tell you which you need to input. Well, I should have known that one. That's just 0.1, which is the same as 10%. If I multiply it by 100, I'll get 10. Okay, so 10% of the sample is contained within this first class. And then 2 divided by 30, I'm going to round this to 3 places rather, so 0.067. And the next one, 5 out of 30. And if I round this one, 0.167. Now we've got 6 out of 30. And guys, that's just an even 0.2 or 20%. And then 7 out of 30. 0.233. 0.233. 4 out of 30. 0.133. finally, 3 out of 30 again is another 0.1 or 10%. Okay. Now at the end here, if you were to add all of these up, it should come close to 1. If it's not exactly 1, that's just due to round off error. Okay, but it should be pretty close to 1. Now, if these were in percentages, it should add up to close to 100%. Okay, so we could say like, you know, this one right here, this particular class contains about 20% of the data. Now, the cumulative frequencies go like this. For the first class, it's just the frequency of that class, 3. For the second class, it's the frequency of that class plus the frequency of the previous class. So 2 plus 3 is 5. And then it just keeps going like that. Cumulative frequency for the third class is 5 plus the 2 from the previous class plus the 3 from the class before that. So that is a total of 10. And then this next one, we've got 6 in this class. Another way to do this, guys, is just look at the previous cumulative frequency. I've got 6 in this class and 10 in the other classes below it. So 6 plus 10 is 16. And then I've got 7 in this class plus the 16 is 23. 4 in this class plus the 23 below would give me 27. And finally, 3 in this class plus the previous 27 gives me 30. This is what I was talking about. At the end here, the cumulative frequency that's in the last class should be the size of your sample, 30, because within this last class we have accounted for all 30 data values. Okay. And guys, I think I may go ahead and stop right here for the first half, and then we'll finish up the second half.